Okay, in this lecture we're going to talk about absolute value inequalities. Remember, we're talking about the absolute value being how far a number is from the origin, the distance, so it's always positive. So if I'm looking at a situation where x is, say, less than 4, so that's saying the absolute value, say, of a number is less than 4, this is telling me that if this is 4, then of course the x value could be anywhere in here, because the distance, alright, from x to 0 would be less than 4. But of course, coming out here to negative 4, it could also be anywhere over here. Okay, so x in here would mean that distance there is less than a distance of 4, right, from the origin. Right, so keeping that in mind, we're talking about an inequality now. And we have some properties again that we need to look at. All right, now the first property, all right, has to do with the fact that if the absolute value of A is less than some number B, all right, this is true if and only if, all right, we have that A is less than B but greater than negative B. And of course we could have less than or equal to here as well. All right, secondly, number 2, if the absolute value of A is greater than B, or greater than or equal to B, doesn't really matter. This is true if and only if right, A is less than negative B, or A is greater than positive B. So notice we have 2 inequalities to look at here. Right, so let's do an example. Okay, let's solve. Okay, the absolute value of 4x takes 6 is less than 10. Right, so by property 1, what this is really saying is that 4x takes 6 is less than 10, which is greater than negative 10. Notice that this is now a 3-part inequality, which we know how to deal with. So notice we have a positive here, all right, and have less than or equal, less than's here. All right, then we just simply add 6 to every side. So this means that we're going to have negative 4 is less than or equal to 4x, which is, less than, I should say, less than, which is less than 16. We now divide through by 4. So this is going to tell me that x is less than 4, but greater than negative 1. So my solution is an interval, all right, and it will be from negative 1, it's not including negative 1, to 4, okay, like so. Right, so let's just change the question a little bit for this second example. Right, let's suppose I now want to solve the absolute value of 4x takes 6 is greater than 10. Okay, notice that this is now property 2. All right, so this is going to mean we need to break it into 2 inequalities. So it's greater than 10. And we have 4x takes 6 is going to be less than negative 10. Okay, we go ahead, add 6 here. So I'm going to have 4x is going to be greater than 16. X is going to be greater than 4. Okay, here I'm going to have 4x, add 6 to both sides, is going to be less than negative 4. So x is going to be less than negative 1. So if you look at a number line here, what we have is here's 0, so here's negative 1. So it's less than negative 1, not including negative 1, but it's greater than 3, 4 here, like so. So in other words, the solution then is going to be from negative infinity to negative 1, not including negative 1, union with 4 to infinity. And that would be my solution. All right, now sometimes it's a little bit more difficult because we have to get it into a standard type of form here where we have a number over this side. And so let's look at this example here. Let's suppose I want to solve the absolute value of 5 minus 8x plus 6 is greater than or equal to 14. Right, the first thing to do is when you've got this negative 6 here, we need to get all the numbers together. So we'd have the 5 minus 8x, the absolute value of that. Subtracting 6 from both sides means I'm going to have this greater than or equal to 8. Okay? Right, now it's greater than or equal to, so this implies I'm going to have two inequalities. Like so. So it's a property 2 again. So let's look at this one. We subtract 5 from both sides. So I'm going to have negative 8 is going to be x is greater than or equal to 3. Notice we have a negative here, so this is going to imply that negative 8x divided by negative 8 is going to be, we switch around the inequality, 3 on negative 8, which implies that we have x is less than or equal to negative 3/8. This one over here again, negative 5 here. I'm going to have negative 8 is x is less than or equal to negative 13. And of course, now we're going to have negative 8x divided by negative 8 is going to be greater than or equal to negative 13 over negative 8. Which means that we have, this implies that x is going to be greater than or equal to 13/8. Right, so if we do a little number line here to see how this is going to work, so let's suppose here's 0. Alright, so here would be negative 3/8, like so. So it would be this direction. And 13/8 is 1 and 5/8 by the look of it. So here's 1, so 1 and 5/8 suppose is here. And it's this direction. So our solution then is going to be negative infinity to negative 3/8. And that's going to include 3/8, so square parentheses. Union with, and this time we're going to include also 13 on 8 to infinity would be our result. Okay. Alright, so that's how we do that type. Now, a couple of special cases to keep in mind. What if I have something like this? Suppose I have the absolute value of 6x minus 9 is greater than negative 2. Now, straight away, when you look at this negative 2 here, we know that the absolute value of anything is how far something is from the origin, and is always positive, because this is always positive no matter what x is. And so since no matter what x is, this is always positive, and a positive number is always greater than a negative number, then this is true for all x, no matter what it is. And so my solution is all the real numbers, which we write like this. Okay? Alright, so special cases, example 1 there. Right, example 2. What if I have something like this? Let's suppose I have the absolute value of 2 take 5x is less than or equal to negative 5. Now, again, notice that this is always positive. we have an always positive number being less than -5. A positive number can never be less than a negative number. So this is never true. All right, for any value of x. So the solution would be the empty set, so we can do an empty set like this, or this. Okay, do not put this inside this because that would make it wrong. Okay, that would say that this set contains this empty set. All right, so that would be our solution for that. Right, now where do we use this? Well, we use it for things like tolerances. All right, when we're making things in manufacturing, we can't make them precise, but we can make them nearly precise, and we always have a certain tolerance that makes it allowable. So let's suppose I have an example that says I want to write K, right, is no more than 9 units, okay, from 3. Now notice that K is no more than 9 units from 3. So K, we're measuring the distance between K and 3. This is the most common error, is that people think it's from 9, but no, it's 9 units from 3. K is no more than 9 units from 3. So K, we're measuring K from 3. So let's look at K, the difference between K and 3, and the size of that is no more than 9. So it must be less than or equal to 9, because that would mean it's no more than 9. And this would be a way that we'd write this particular statement in terms of an absolute value. So let's do that as example 1. So example 2, what if I have a statement like T is within 0.02 units of 5.8. Okay, so T is within this many units of 5.8. So what are we measuring to be within? All right, well, the difference between T and 5.8, that difference, right, must be less than, it's within, okay, not equal to, but within 0.02. And that's how we write this particular statement here as an absolute value.